Okay, this review is from section 5.7, and the first problem says write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and has the given zeros for 1 and 3i. So first of all, I would just remind you, a function of least degree just means however many zeros you're given, that should be the degree of the function. So don't assume you have any repeated solutions. You should also have rational coefficients. So, like 3i is not a rational number. So in your final answer, you should not have any imaginary parts. And then lastly, your leading coefficient should be 1, which means you don't have to worry about a. You don't have to worry about a being anything other than 1. So you have these 3 zeros, but then you also have to remember that when you have imaginary zeros, they always come in pairs. So negative 3i is also going to be a 0, and that's tricky. So this is actually a fourth degree function. And if you didn't catch that imaginary solutions come in pairs, you're going to be in a world of trouble because you're only going to have a cubic and it should be a quartic. You're also going to have i's in your function, which is not rational. So, it's a big point problem. So just make sure you really take your time with this. So I'm going to take my zeros and I'm going to set those up as factors. So if I have a 0 of 4, I know my factor is x minus 4. If I have a 0 at 1, I know my factor is x minus 1. If I have a 0 at 3i, I know the factor is x minus 3i. And lastly, if I have a 0 at negative 3i, I know it's going to be x minus a negative, so x plus 3i. And then it really doesn't matter how you multiply, but just remind yourself it's always easiest to multiply the conjugates first because that should get rid of your i's and it makes your life a lot easier. So I'm going to start with foiling out these two first. So actually, you know what I'm going to do, because I think you're going to be fine with this. I'm going to FOIL these out, and then I'm going to FOIL the conjugates out. Okay, so first, when I FOIL, I get x squared minus x minus 4x plus 4. And for my conjugate pairs, I get x squared plus 3xi minus 3xi minus 9i squared. So then I'll simplify, of course. Starting with this one, I can combine to get a negative 5x there, so that's x squared minus 5x plus 4. And here I note that my plus 3x and my minus 3xi cancel out. And also note that I squared is negative 1, so this is really a minus 9 times negative 1, which is plus 9. So that's just x squared plus 9. Now I can FOIL out or multiply out the two quadratics. So I get x to the 4th plus 9x squared minus 5x squared minus 45x plus 4x squared plus 36. I made a mistake somewhere. Where did I make a mistake? Minus 5x cubed. There we go. I think everything else is good. Okay, and then I'm combining like terms, and I am done. So x to the 4th, and then I have minus 5x cubed. Takes care of those. And then I have 9 plus 4, so 13x squared minus 45x and plus 36. So here's your polynomial function of least degree, so fourth degree because I had 4 roots. Leading coefficient of 1, everything is integer coefficients, there's no i's in my final answer. And it's not a challenging problem, it's just obviously a lot of places to make mistakes, so take your time. Okay, last one here. It says to find all of the zeros. Now there might be some of these questions on the calculator and the non-calculator portion of the exam, so let's just play worst case scenario and say that this that this were maybe a no calculator question. Okay, so finding the zeros, well, first and foremost, you should know you're going to have 4 zeros, right? Because you have a 4th degree function. I don't have my graphing calculator, so maybe I should start by listing possible rational zeros. So possible rational zeros are all of the factors of 9. So 1, 3, 9 divided by all the factors of 2. So that means I could have 1, 1/2, 3, 3/2, 9, and 9/2. Now you, if this were a test question, what I probably would do is I would probably give you a hint, and I would tell you one of the zeros is either 1 or -1, because those are pretty easy to check mentally. So let's say you check 1 mentally. If you put 1 in for all of these x's, you're going to have 2 plus 1, which is 3, plus 3, which is 6, plus 6, which is 9, minus 9 is 0. Okay, so I would, if this were a no calculator question, I would give you a hint that 1 or -1 works. Okay, so let's say you tried 1 first. So knowing that, and I might give you a couple more hints, okay? So that's what you would have to do is take my hints. Now let's say that this were a calculator question. I certainly hope you would graph this, because it would not be fun to sit and test all of these. Okay, so take advantage of your calculator. And when you do graph this, I'm just going to kind of just do a little sketch here. You see this. Okay, so it's pretty clear from my calculator that it's crossing at 1, and then it looks like maybe -1.5. Okay, now you can actually calculate those on your zeros. Remember, you have the 0 feature under your calculate menu. And yes, this is -1.5, and this is +1. Well, +1 and -1.5 are both possible zeros. And that's the only 2 I can get from my calculator. So I know 2 of the 4 are real. The other 2 must be imaginary. So here we go. We've got to work our way down from 4th degree to quadratic to solve for those 2 imaginary solutions. Okay, so I'm going to start with synthetic. And I'm going to start with, I know 1 works, and I know -3/2 works, only because I looked on my calculator. Okay, so the coefficients are 2, 1, 3, 3, and -9. And you do the synthetic process, and you get a 0 remainder. Awesome. Okay, then reminding you that we started with a 4th degree, so this is 3rd degree, and I'm going to bank off it one more time with -1.5 and do synthetic there. Okay, and I get a 0 remainder. So again, I knew that 1 and -3/2 works. Now I went from 4th degree to 3rd degree to a quadratic, and I have no x, so I'm actually going to, of course, rewrite this. So I have 2x squared plus 6. Well, I can solve that. First I'm going to divide everything by 2 to make my life easier. Then I can subtract 3 over to the other side, square root both of those, and I get plus or minus I root 3. So there's my 2 imaginary, and then I knew that 1 worked, and I knew -1.5 worked, and there's all 4 of my solutions. Okay, so let me recap again. If this were a calculator question, you would want to graph this on your calculator and calculate the zeros to help you get going, right? So we went from 4th degree down to 3rd degree down to 2nd degree. And I will always give you a problem that you'll be able to get down to a quadratic for sure. Then the quadratic, if it's not factorable, then you have to solve using the quadratic formula, or this one you could just square root things. So it should work out for you.